Welcome to the world of chemistry. Today we want to talk about acids and base. And we're going to begin with a simple definition of an acid. An acid gives hydrogen ions. And I should say when dissolved. For a substance to give hydrogen ions, it might be a substance like H hydrogen chloride or hydrochloric acid, so where the hydrogen is the positive part and the chloride is the negative. So when that dissolves, you get hydrogen ions plus chloride ions. Substances like CH4, methane, that's not an acid. It's got hydrogen in it, but the hydrogen isn't the positive part. The carbon is. And so, or you also would say this, NH3, it is not an acid because the hydrogen is not the positive, the nitrogen is over here. So to understand that every substance that is an acid has to contain hydrogen, but it has to be the positive part. A base is simply is going to be called it can give hydroxide ions or can accept hydrogen ions. A simple example of a base is sodium hydroxide. When it dissolves, you get sodium ions plus hydroxide ions. But this is also a base because NH3 can react with a hydrogen ion to form NH4. So this is a base in the sense that it accepted a hydrogen ion. This is a base in the sense that it gave hydroxide ions. So that's just simple definitions. We have many ways to test to see if a substance is acid or base. And it's a very important. Our stomach is about 0.1 molar, is about a pH 1. So let's take a look at some of the simple ways to test for acid. One of the ways in which we test for acid is called indicators. An indicator it changes color depending on the hydrogen ions present, how many, or missing. A good example of an indicator would be litmus paper. And I have here an example of litmus paper. So I'll start here with a list of litmus paper. And there are two kinds of litmus paper. Let me show you. I have blue litmus paper and pink litmus paper. So I'm going to hold this blue litmus paper right here in the middle. And in this side, all these wells here have a base in them. All these wells over here have acid in them. So I'm going to start here, and I'm taking the blue litmus paper and putting in base. And guess what? Blue, no change. Blue is still blue in that. Let's turn this over and put the same blue litmus into that, and what you'll see is a pink color. The result of that indication is an interesting saying. Blue to red, this pink or red, is acid. It's kind of rhymes. Blue to red, acid. And if you have blue to blue, it's no change. If you have red the blue, it's base. Let's try that. Here's red or pink, and we're going to put that in blue, and sure enough, the red, the blue is for base. We're going to put that in base, put the other end in acid, and no change. So with regard to litmus paper, if you put pink litmus paper in base, it will go blue. Pink in the base goes blue. If you put blue litmus paper into acid, blue to red, acid. We have other indicators that are kind of fun to look at, and so I thought I would just try a few of these. One of these is methylene blue. And methylene blue, we'll just use the first well, put a drop of methylene blue there, and it's very yellow. We'll come over here to the base and put a drop of methylene blue there. It's very blue. So methylene blue is an indicator that's yellow in acid and blue in base. There is another indicator, methyl red. We're going to put a drop of methyl red into the acid, and it's very red. Come over here and put it in the base, and it's yellow. So what you see is methyl red is red in acid and yellow in base. There's another one, brome cresol green. And these are big words, but it's interesting, very often they're named after what color they are in base. Here's brome cresol green. In acid, it is yellow. In base, a little more, it's blue. And actually right in the middle, when it's not acid or base, it's green. And finally, one more is a universal indicator. Universal indicator, not only in the acid it's pink, and in this it's purple. And I don't know if you can see that, but on here, this color scale, at all the different acidities, the most acid will be the red pink, and the most blue will be the purple, but all the different colors in between, you put a drop of that in and match the color, and you'll be able to tell the acid or the pH. And I haven't defined that yet. I have one more indicator which is very commonly used, and this indicator is phenolphthalein. And if you put a drop of phenolphthalein in the acid, nothing happens. It's just clear. But put it into base and it's very, very pink. So these are indicators that tell us about the acidity of a substance. So I want to look at the scale of acidity. It's called the pH scale. And it runs all the way from 0 through 7 to 14. Down here, the lower, and it's called the pH, is acid. Up here is base, and here is neutral. So anything that's acid is going to have a pH less than 7. Anything that's base is going to have a pH greater than 7. If it's neutral, it'll have a pH of 7. So this important scale can be gotten to by indicators. Let me do a mathematical definition of pH. pH equal the negative log of the hydrogen ion concentration. And you may remember that the hydrogen ion concentration of water itself, and I'll give it to you, its molarity in water is equal to 1 times 10 to the minus 7. And you may not be familiar with what logs are, but logs are just the exponents. And so you see the exponent of this number 7. So the log of this number is negative 7. The negative log is 7. So this is pH equals 7. So there'll be some help with you in that. But you understand that the pH less than 7 is acid, the pH greater than 7 is base, and the pH at 7 is neutral. And we have many, many ways to measure this. I have an example here of a pH meter, and I don't know if we can get in on that. Is that visible for you? I have to set it up here. Okay. Here's this pH meter, and we have, you know, in the lab we have these little portable instruments that can be carried outside, inside, and it's hooked up to a probe that's called a pH meter. And basically what I can do here is I can stick this pH meter in, say, this beaker, which it says it's an acid, and you should observe pH going way down. It's actually less than 1. There. So I put a drop of acid in that still water, and the pH is about 2.8. You can read the pH. And you can do the same thing with base. You can look at something. I'll put some base in here. And we'll just move that over, and the pH should go way up. So we got about 10 still moving. pH 10. So the pH meter has the ability to read off the pH just by sticking the probe in the water. And of course we have calibration standards for all of that. So I want to show you what I can do with a pH determination, a chemical reaction. This particular demonstration is a titration. And I have in this burette, I have exactly 0.1 molar sodium hydroxide. And down here, I have about 15 milliliters of acid. And I don't know its concentration. But what I can do here is I can do a chemical reaction, and I'll put in phenolphthalein. Now I'm putting phenolphthalein in the acid. And do you remember what color phenolphthalein is in acid? It's clear in acid. And then I can add the base to it. This would be the titration. And as I see right here, the top of this is 0. So if I go ahead and just add the base, I'm going to add that, swirling and adding the base, and watching, you'll see a pink color is kind of arising there. It's trying to change. The moment that this goes basic, that means all the acid is neutralized. We should get a pink solution near the end point. And you have to practice the mix and titrate, but I'm near the end point on this. Fades a little. That's not going to fade. Yes, it is. That's the only thing that students don't like about phenolphthalein. It has a fading end point. And that then should give us very near. One more drop will do it. Okay, that's going to go to a faint pink. See, I can use another drop. So this is what we do in analytical chemistry. We titrate to the end point of a reaction. Okay. Then I read this and I say that it was 17, actually it was 17.01 milliliters. So it took 17.01 milliliters of the base, which I know the concentration of, to neutralize 15 milliliters of acid. So you can see that the acid is a little bit stronger. If I wanted to calculate this, it would be calculated this way. The molarity of the acid times the volume of acid equal the molarity of the base times the volume of base. And so since we know the volume of acid, 15 milliliters, we know the volume of base, 17 milliliters, we know the molarity of the base, we can say that the molarity of my acid is equal to 0.1 molar times the volume of the base, which was 17.01 divided by 15.01. And what you'll see then is that the molarity acid, the acid was a little bit stronger than this because it took 17 milliliters to neutralize 15. So that is an example of a titration, quantitative use of the stoichiometry one-to-one. The last idea I want to mention about, I'll move this over here so you can see what makes acids. Well, in this beaker I have just distilled water and some phenolphthalein. The fact that it's clear colored means that it is neutral or acid, because phenolphthalein is clear till it gets up to 8, and then it changes about pH 8. So what I'm going to do here is I'm going to take calcium and I'm going to add it, this is a metal, and I'm going to add it to water, and you'll see I will get some calcium hydroxide, plus you'll see some hydrogen too, okay? Or you'll get I think you'll get calcium oxide. Let's just do that. Sorry. You'll get calcium oxide. But it'll be in water. Okay? So the point I want to make is that metal oxides, when they dissolve in water, are bases. So this should be a base in water. And then the second thing I'm going to do, I'm going to take carbon dioxide and dissolve it in water, and I should get carbonic acid, H2CO3, an acid. So let me repeat what I'm trying to show you. I'm trying to show you that metal oxides dissolved in water create bases. Non-metal oxides dissolved in water create acids. So to create I'm going to use calcium metal, right here it is, and a pair of tweezers. I'll just put a little in there and see what happens. Right away, you see the bubbles of hydrogen coming off, and you see the reaction going. The pink color means what? When phenolphthalein turns pink, means you have a base present. So the calcium is dissolving, producing hydrogen gas. You see the bubbles. This is similar to sodium and cesium, but this is an alkaline earth metal that dissolves in water, producing the calcium oxide, and the water solution makes a base. Well, that's gone. We're looking right here at a solution of water that has bromethymol blue in it. In case you don't remember what bromethymol blue is, it is yellow when it's acid, here's it, and blue when it's base, or neutral, near neutral. So this bromethymol blue is near neutral, and I'm going to just blow some carbon dioxide in it, because you exhale carbon dioxide. Carbon dioxide dissolved in the water, turned it yellow, means that it is an acid situation. So in general, let's say that that we'll work, with our calculators. We'll work on getting the pH of a solution. We'll work with the pH scale and show you how to get the log on the calculator. I'll probably be putting up some directions on the program. So acids and base, and this is kind of our closing chapter, our last chapter for this this course. So thank you. I've enjoyed talking to you, at least via video. Thank you.